let's learn how to use PIEFrames generator to create event frames in Asset Framework using trigger tags. We're going to be using the following steps. First, we're going to determine our active points and event name points. We won't be creating these tags in this video, but we are going to discuss in depth how they are used by PIEFGen to create event frames. We've already created our AF element templates and built a hierarchy of assets. And in the following video, we're going to be linking those assets to specific child event frames or unit batch and sub batch levels in our event frame hierarchy. In this video, we will start the interface to create the base event frame templates, and we'll create derived templates that will be used in this video. And then we're going to go step by step how to configure PIEFGen using the PIEVentFrames interface manager to create event frames in Asset Framework. And then we're going to use PSE to search for those event frames and verify that they have been created. So let's start by looking at what's necessary for a proper set of active points. Here's the parent level of the example event frame that we'd like to create. And here it has a name of 5094. Within that parent event frame, this batch or this process is going to go through 3 different units for processing. It's going to go through mixer 1, mixer 2, and also a heater unit. And within that heater unit, we also need to capture the times that various heater elements were on, and in the name of that sub-batch, what level, for example, element 1 was at. So this is the event frame structure that we would like to capture in this video using PIEVentFrames generator. In the following video, we're also going to specifically link the unit batch level and sub batch levels to their corresponding hierarchy in Asset Framework. And we're also going to learn how to add in custom attributes. For instance, the tag value at evaluation time, which we'll configure in PIEFGen, or the attribute value from the referenced element as configured in the Derived EF template. So let's go ahead and look at more details of where the actual active points or start and end times and names for these event frames come from. In this case, we have the parent level 5094. And the start and end time is going to come from a tag. In this case, I have it named L1 BatchID active point. And if we look at that tag in the data archive, you can see that there's a value of 1 at 2 p.m. at 09 seconds, and then it goes back to 0 11 minutes later. And this actually corresponds to the start and end of a batch. Now, if we want to look at where the name of the event frame comes from, we're actually going to link it to a tag, in this case L1 BatchID. And at the start of the event frame, it has a name of 5094 in that tag. So that's actually how we're going to use these trigger tags with PIEFGen to determine the start and end time and the name of the batch. In this case, we're using pulse mode for the active point of the batch. In that case, anytime the L1 batch active point goes to a non-zero value, it will open the batch, and when it returns to 0, it will close the batch. We'll be discussing step mode a little bit later. And again, we're not going to discuss how to create these BatchID and active point tags. We're assuming that you can use analysis service or performance equations to create these tags. And this series of videos discusses how those active points are used by PIEFGen to create multi-level event frames. So we just discussed the parent level event frame, but we also want to discuss the child event frames that correspond to specific units or unit batches. In this case, our process goes through mixer 1, and we have an active point called L1 mix1 active point. You can see here there's a 1 and a 0 that correspond to the start and end time of this unit batch or child event frame. And the name comes from a separate tag called L1 mix1 BatchID. And the name at the time of the start of this unit batch is L1 mixer 1 5094. The same goes for mixer 2, with the start and end time coming from L1 mix2 active point and the name coming from L1 mix2 BatchID. We also go through a heater step. In this case, we have heater 1 active point with a start and end time that corresponds to the start and end time of the unit batch. And the name here comes from the L1 heater BatchID. We also have sub-batch levels inside of heater 1. Here's the start and end time. In this case, we're using a static name, so the name of that sub-batch will always be heater element 2. And then finally, we have this heater 1 element 1 active phase. In this case, the name of the active point goes between heater element 1 medium, heater element 1 high, and off. And in this case, we're going to use the actual value of that tag to correspond to the name of the event frame. We're using steps in this mode, so when the tag goes from a value of heater 1 element 1 medium to heater 1 element 1 high, it closes the medium event frame, opens the high event frame, and then off is our 0 state. So that means that those event frames should close. So we've looked at how to open and close parent event frames and child event frames at multiple levels, and also how to name the event frame, either using a separate tag value, the same tag value as what is used as the trigger, or you can use a static name. But we can also fill in the other default batch attributes like product, recipe, batch ID, etc., using tags that will be evaluated at the specific evaluation time of PIEFGen, which is configurable. I should also make a note that there is something known as PIBaGen compatibility mode, where the information that you provide to the interface is the start and end times of the units, and also what batches those units are supposed to be associated with. So in this case, you provide the start and end times of mixer 1, mixer 2, and heater 1, and you add in a piece of information about what event frame that should be associated with or what batch ID. At that point, the interface then looks at the earliest unit start time and the last unit end time, and overall it will create an overarching batch that corresponds to all of those units. So there's no explicit start and stop triggers for that parent event frame. It basically uses the earliest and latest triggers for the units to then determine what should be the overarching parent event frame. And we won't be going into details on this, but this is known as PIBaGen compatibility mode. Now that we've determined the active points and the event name points, we're going to for now skip the AF element templates and hierarchy of assets because those are going to be linked in the following video. Let's create the event frame templates. So let's start by hopping into our system and create the default templates by starting up the interface for the first time, and then we'll create the derived templates. Here I have my interface machine. Let's go to Pi Event Frames Interface Manager. Going to create a new instance of the interface. So I'll say add interface, select PIEFGen, and this will be service ID 1. Under server information, you'll see that PIAsset server settings, create event frames in PIAsset framework has already been selected since this interface does not create batches and can only create event frames. And under select asset server, I'm going to choose prod as the server I'd like to use to create my event frames. Event frame structures where we're going to configure the active points to create the parent level event frames and all the child levels. But before we do that, let's hop into PySystem Explorer and take a look at the event frame templates that are currently on our server, because the interface on startup is going to create a set of base event frame or batch templates. And we're going to want to create a derived template for those from those to use for PIEFGen. So we need to get those base templates created. So I'm going to open up PySystem Explorer. Make sure I'm in my prod database. And if I go to the Elements tab, you can see our asset hierarchy, which is going to be used in the following video to link these to our event frames as the primary referenced element. But in the library, I can see that there are element templates, but if I try and expand the event frame templates, you can actually see that there are none here. So I need the interface to create those before I can create the derived templates. So let's go back to Event Frames Interface Manager. Be sure to hit save at this point. I'm going to go to service configuration. For logon as, make sure to input the service account that you would like to use for the interface. I'll hit create service. If I go into services, you should be able to see the newly created service. And then I'll go ahead and start the interface service. Since we haven't configured anything in the event frame structure, at this point, it's not going to create any event frames in Asset Framework, but it should connect to this database and create some new event frame templates for us. So if I go ahead and hit refresh, you can see that it's created some nice base templates that are used by default for the interface. We could use these templates for the event frames we're about to create, but if you need to make any custom changes, adding special attributes to your event frame templates, it might be nice to first create some derived templates. So what I'm going to do is create 3 derived or 4 derived templates actually. First, under PIBaGen Procedure, I'm going to create a new derived template from this event frame template, and I'm just going to call it Procedure Factory 1. I'm going to do the same for PIUnitBatch. Under Unit Procedure, I'm going to create 2 derived templates. One will be called Unit Procedure Heater, which we'll use for our heater units or our heater event frames. And another one called Unit Procedure Mixer. And finally, I'm going to create a PISubbatch phase. I'm going to call it phase heater element. And we'll be using these when we set up PIEFGen. Now that we've started the interface to create the base event frame templates and created derived templates from those, let's go ahead and configure PIEFGen using PIEVentFrames Interface Manager to populate our event frames in PySystem Explorer. So now that we've started the interface and had it create the default batch event frame templates, and we've manually created some derived templates that we're going to be using, let's go back to PIEVentFrames Interface Manager. We'll stop the interface and let's go to the event frame structure tab and start creating the linkages between the active points, the names of our event frames, and actually have it create some event frames for us. So if we go to the EF config tree, I'm going to right click and say add new event frame. And this is going to be where we configure that first parent level event frame, none of the units yet. And at this level, you can see that there is this PIBaGen compatibility mode. And this is the other mode, not the mode we're going to be using, but the mode where it uses the start and end times of the units and what batch we tell it they should be associated with to then create the start and end of that parent batch. So if you notice when you click on that, the majority of the information for this tab goes away because you don't explicitly have a start and end trigger for the parent level batch. But in our case, we do, and we're going to use that active point in just a second. So first, let me rename this configuration to parent level, and always be sure to select your event frame template at the beginning, because if you select it later on, it's actually going to force you to clear out any configuration that you made down here in the attributes section. So here I have named the configuration node and selected my event frame template. Now our active point is going to be L1 batch active point. So let me go ahead and find that. And we're going to set that to pulse. Since anytime it goes to a non-zero value, we want to open, and then when it goes back to 0, we want to close. And we're going to name the event frame based off of whatever the value of a tag is at the start of the event frame. In this case, I'm going to say it's L1 batch ID. And when the batch opens, it's going to go and look at whatever value there is in this tag and name the event frame appropriately. Now, if we know that it takes some time for this to evaluate correctly, we can, on the referenced element tab, add in an evaluation delay or evaluate at the end time. However, you should note that this doesn't just create a delay in the evaluation, it actually changes the timestamp that is evaluated of that tag. So for instance, let's say the L1 batch active point says that the batch should open at the top of the hour, but we've put in a 10-second delay. It will actually reference or it will query this tag for what is its value 10 seconds after the hour. So it doesn't just put in a delay, it also changes the time that's queried. And that's also true for these attributes down here that we can capture. So I have tags that correspond to the product and recipe. So I'm going to also set up those PIEpoints to be queried by PIEFGen to capture those values. So first, let me find the product that's being made. And the recipe that's being used. And here we've configured our parent level by choosing the tag name that would be our active point, how we want to name the event frame, and we've configured the product and recipe, in addition to selecting a special derived template that we created in AF. Now under this parent, we have mixer 1, mixer 2, and heater 1. So I'm going to right click on the parent level and say add new child event frame. And I'm going to call this mixer 1. And before I do anything else, be sure to select the derived event frame template that we created earlier for the mixers. My active point here, I'm going to call mix, actually L1, mix 1. So let's find the L1 mix 1 active point. And this will also be pulse. So when it goes to a non-zero value in this case, it's going to open the event frame, and when it goes back to 0, it's going to close it. And I'll name it based off of a PIEpoint value. That would be the L1 mix 1 batch ID. And then same thing, I'm going to configure the procedure, product, and batch ID down here, since I do have PIEpoints that hold that information. And in this case, I'm actually going to use the batch ID at the parent level to populate this attribute in my event frame. However, you should note that it checks the value of this tag at the start of this unit level, which might be different than the start time of the parent level. And here I've configured mixer 1. Let me do the same for mixer 2, and then we'll move on to the heater after that. And here we've configured mixer 2, so let's move on to heater 1. I'm going to use the special derived template we created specifically for heaters. So if we were to make edits to that, that would then translate to these heaters. And I'll go ahead and configure my active point. And I'll go ahead and hit save. Now, if you remember, we have two different heater elements. Heater element 1, you can see that the L1 heater 1 element 1 active phase tag here, the name of this tag we've called phase, cycles through different string values of heater element 1 medium, heater element 1 high, and off, where we're using pulse mode and a 0 state of off. So it will, and we're actually going to use whatever value is in the string tag to actually name the event frame. We also have heater element 2 here, where we use the heater 1 element 2 active point going between 0 and 1. In this case, we use pulse. And then we're going to just give it a static name of heater element 2 anytime this one opens or closes. So let's go ahead and configure these two as well. So if I right click on heater 1, I'm going to say add new child event frame. And let's start with heater 1 element 1. Going to choose the appropriate event frame template. And I want to make sure to use the one with active phase, since that was that string tag that goes between high, medium, and off. And I have to be sure to use step in this case, so that when one phase closes, the next one opens. And in this case, the name of the event frame is going to be the same or the value of the string tag that's used to open and close these. So it's the actual value of that phase tag. And let's also create heater element 2. And we're going to choose our event frame template. We find the active point, which will be pulse. And we're going to use a static name. Let me say heater 1 element 2. And I'll go ahead and hit save. If I go back to service configuration, let me go ahead and start the interface, and then we'll wait a few minutes while it creates those event frames. Let me hop into PySystem Explorer. I'll go over to the Event Frames tab, right-click, say New Search. I'm going to uncheck all descendants since I only want the parents to show up in this list. And if we want to see the children, we can go ahead and open them. I'll hit Search and click OK. And let me select one of these event frames. Here we have 6057, for instance. Under it, we have L1 Mixer 1 with this start and end time, L1 Mixer 2, and then L1 Heater 1. And then within there, there's the Heater 1 Element 2 with a static name, along with the Element 1 Medium and Element 1 High sub-batches. If I go ahead and look at the Attributes tab, I can look at the parent level. And we'll be able to see that the product and recipe are filled in, and these are actually the values of that those tags had at the start time of the event frame, as well as the batch ID, procedure, and product for mixer 1, mixer 2. The heater also has a batch ID, procedure, and product, and there were no special attributes added for the heater elements themselves. You should now be comfortable using PIEFGen's generator. We've discussed how the active points and event name points are used by PIEFGen to create event frames and to fill in the name of the event frame and the attributes. We have not yet used the AF templates or the hierarchy of assets. That will actually be completed in the next video where we link units, physical units, to the first level child event frame units and also the sub batches. We've shown how the interface creates event frame templates. They create base templates the first time an interface is started. Any batch interface is started connecting to that AF database. And then we created derived templates, which we're going to use in the next video to show how you can create custom attributes that reference the units that are associated with those event frames. And we went step by step through configuring PIEFGen using Event Frames Interface Manager, and then confirmed that we did create the event frames as expected using PySystem Explorer.